Hello there and welcome to my next tutorial. In this tutorial I'm going to be doing a C# platform movement in 2D. I put a link in the description there, but I had done a Bolt tutorial where I did the most simple 2D platform controller that I could, and I've had a request from some of my students to do this in C# so we can compare how one works and how they and whether C# or Bolt is easier or quicker. So we're just going to quickly do what we did in the Bolt tutorial. All we're going to do is going to create a sprite. So I'm just click on sprite and create a square. So I've got a basic square. This square I can use multiple times. So on my hierarchy here, I'm just going to create a 2D object. I'm going to create a sprite here. I'm going to call this one player. And we're going to add the sprite onto the sprite renderer for this player. So we'll drag the sprite onto the sprite renderer here. We'll leave this as white. And we're going to create another one, so another 2D object. That's going to be another sprite. This time we're going to call this platform. This is going to be my platform. And as we did before, we're going to drag the sprite onto the sprite renderer component. And this time I'm going to change the color. Oh, my color popped up over here to maybe blue for the platforms. So I'm just going to move the sprite down for the platform. They give us something to land on, and this is the main one. This is going to be white. So let's set the platform up first. It's nice and easy. We just need, from the Physics 2D menu, we just need this box collider so that it's got a collision shape so that the player can land on it. And the player is the key thing that we're going to be working on for this tutorial. We're just going to try and get very, very, very simple 2D platform movement. So the two components that we're going to need is some Physics 2D components. So from the Physics 2D menu, if you create yourself a box collider, I'll just use a box collider for now because why not? And also we'll need to get a rigid body 2D as well. So you'll see that down the list, rigid body 2D. So we can leave all of these values as they are. One thing that you may want to do is just freeze the Z rotation so it doesn't accidentally get spun around when it hits into things. So this will stop it from spinning if it does get knocked or hit into things. Everything else is just going to be controlled by code. Just like we did in the Bolt tutorial, the key element here when you're doing any coding and you're problem solving for code is that you just work out what component it is you want to act on, and then you want to have your script grab that component and then do the stuff that it needs. And remember that the question mark is here. So if you want to find out what this rigid body 2D component is and how it works and what its scripting reference is, you just click the question mark and you'll be able to look up in the documentation. And that's one of the first places you should be going to try and work it out. So I'm just going to make myself a 2D script, and we're going to call it platform movement. So we're going to do this one in C# instead of Bolt, and we're just going to get to compare how easy or easier or harder it is in order to do. So we're going to drag this straight onto the player. So I can select the player here and just drag this on as a component, so we can put this anywhere we want inside. So I'll just check up the top here. So this platform movement, we're just going to get open inside of Visual Studio so we can start coding. So the Bolt script that we used, I have it here. This is just from my YouTube channel. So it's fairly simple, where we get some input from the user and store it in a variable. So we store it in a vector2 variable. And then in the fixed update, which happens on the physics time step, we set the velocity of the rigid body. So it's a fairly simple script to implement in C#. And I'll just give you a quick rundown of how to do that. So first up, what we need to do is get the rigid body. So I'm going to cache this value. So I'm going to create a rigid body 2D, and we're just going to call it RB. There's a couple of ways we can do this. You can actually just make this public, and what we can do is, by doing this, you're exposing it inside the inspector. So if I go back to the player here, we can see that the player has now got, if I get rid of that, so I can see the platform control. It says RB is none, and what it's looking for is a rigid body. So we can actually just drag our rigid body straight onto this component. So you drag the top part straight on. So that gives us access to the rigid body component. The other way is obviously using inside of start. You can use a get component method, but because we've done it in public, we may as well just stick with this. So we'll make sure that you just need to remember that you need to add it in. So we don't need to do this inside of start. That gives us access to the rigid body, as I said, so we can set the velocity. The next step that we're going to take is we're going to have just a vector2 to control the movement speed. So I'm just going to call this move. And I'm going to initialize it here to 0. So I'm going to say vector2.0, and that just initializes this value to 0 at the beginning. So 0 on the x and 0 on the y. So that's all the vector2 is. So inside of update, I'm going to set the y of the move, the x of the move to be equal to the values we get back from input. So we do input.getAxis, and we pass in horizontal. We need to make sure that you spell this correctly. So that will get back the value, either positive 1 or negative 1, if you're pressing the right or left arrows, or the A and D keys. And obviously you can use that to get to be able to move the velocity of the rigid body. So we also want to set the y. So if I'm going to set the y, I want to set it equal to the current velocity of the current y velocity of the rigid body. So I can just say rb.velocity.y, and that's not much to type. So that just handles the physics for us, and we just pass that back in. So when we set the velocity inside the fixed update, we're moving with gravity. So the next step would be the fixed update. So if you start typing in fixed update inside Visual Studio, you'll be able to get the entire method body just like this, and then we can start typing in the code that's going to happen. So the fixed update happens every fixed time frame. So this is the recommended place to do any physics stuff, and all we need to do the physics stuff is to set the velocity of the rigid body. So rb.velocity equal to that move. What we'll do is just save this, jump back, and we'll test this, and in theory we should be able to move right and left. Previously when I set these up, I accidentally set the position at 10, so I couldn't see them, but I did refix that. So when we press play, we should see these sprites. So you'll see it drops to the ground, and you can see that I can turn left and right with the A or D, or with the arrow keys to move it right and left. So we want to make it a little bit faster, so we can just add in a variable that we can multiply those things by, or we can just multiply it when we get the input here. So if we hard code this, we can easily just, as soon as we get the input, so the move.x is equal to this value, which will be between -1 and 1, and we'll just multiply it by a hard coded 10. So that's the speed that we're moving at. If we jump back into our code again, this should move 10 times faster than it did previously. So it's compiled, we just run it, and we should be able to move right and left a little bit faster. To make the code a little bit more useful, however, rather than hard code this value, what we can do is turn it into a public variable. So if I make a public variable of type float, and we'll call it move speed, which is a good name for something that's going to be the speed of the movement, I'm going to initialize that to 10, so set it to 10 right here. And what we can do is use this move speed variable here instead of the hard-coded 10. Why that's useful is when we go back to our inspector, the script that you'll see here has now got this move speed value in here, so you can change it in here without having to go back into your code in order to change it. So when we compare that to the actual bolt script that I made in the video that I mentioned earlier, this is exactly the same. So we've got a bolt script that looks a little bit like this, and the C# version looks confusing if you don't know what C# is, but it's definitely a lot less to type, and it's a lot quicker once you know what it is you need to do. In the next little section of this video, I'm just going to do the jump as well, and I'm going to compare how easy that is to bolt in Bolt and in C#. So the first part of making it jump really is just adding a force to it when you press the one of the keys. So we're going to do this like we did in the Bolt tutorial. We're going to do it inside in fixed update. You'll find that this is a little bit janky because fixed update obviously doesn't run every frame like update does. So sometimes you press space and nothing actually happens. But we'll the simplest way of doing it is by doing it in here, and you can maybe refine it later. So all we really need to do is we're just going to do an if statement. And in Visual Studio, if you type if and then double tap tab, you'll get the entire code block, including the curly brackets. And the cursor gets put here ready for you to start typing. So I'm ready for the condition that it's looking for if. So the condition would be the input manager, and then we're going to do a get button down. So get button down takes in a string name for a button, and again this is in the input manager if you want to take a look, but there's one called jump. The jump button is by default the spacebar. So if we press the spacebar, we want to add a force to the rigid body, so it's as easy as typing in rb.addForce. When you hit the brackets, you'll also get be able to go up and down in the various overloaded methods for this. One of them requires you pass in a force mode, which we need. We need this because we want to do the impulse force mode as well as the direction of the force that we want to do. So if I start typing in, you'll notice the signature is different from these. It's one vector 2, and the other one is a force mode as well. So if you start typing in, it's clever enough to guess. So I'll just say vector2.up. Believe it or not, that's a thing. So that's the direction I want to go in. The amount of force I want to produce for that, I'm going to multiply vector2.up by, I don't know, some random value of 10 for now. And then we need force mode 2D dot impulse, and that will just give it an instant kick in the butt force so that it goes straight up in the air. So this 10 again probably should be a public variable up here, but I'm going to test it without actually worrying about that before I worry about whether I'm going to make it public or not. So we have jumping in theory. So now I can move right and left, and when I hit space, I'll jump. Now the biggest issue with this is jump's really high, but the biggest issue with this is that I can jump when I'm in the air as well. So that's definitely not ideal. I can shoot straight up in the air if I keep spamming the space bar. So I think we should definitely work out a way of doing that in the next part. So the bolt method of doing this was to cast a ray down from the rigid body and work out if it was hitting anything, and then use that as a method of deciding on whether we can jump or not. So in C# it's not too difficult to implement. I'm just going to quickly get on and do it. So the way we do this is we need to pre-make this raycast hit 2D array. So you just need to kind of trust me on this, but raycast hit 2D array is initialized with the type raycast hit 2D, and then you put the square brackets to define that this is an array. The name of this array is going to be called hits, and I'm just going to initialize it to give it a few empty values. So if I say new raycast hit array and just say maybe 5, chances are it'll not hit as many as 5, but once we've got this here, when we use it inside of the rigid body method, when we cast down with the rigid body, it will definitely have enough space for them in there. So we did this inside of the fixed update inside of when we did it with bolt. So in theory, we could do it as well inside of fixed update. So all I'm going to do is I'm just going to create an integer, which it will be a temporary integer for number of hits. So I'm just going to call it num hits. I'm going to make it equal to rb.cast. So this, if you look this up in the documentation, this cast allows us to cast in a particular direction, store that in a particular location, and give it a particular distance as well. So if we look at this, some of the overloads for this, you'll be able to see one of them requires a distance. So I've got a direction, the results in a distance. So we'll go from rb.cast, we'll say the direction will be vector2.down, which makes sense. The array to store the results of that, the cast, is called hits, which I initialized at the very top of my code, and the distance will be 0.55. I know for a fact, because it's a default sprite, that my sprite is around about 0.5 units big, so I'm going to make an array that goes a little bit further on than that, so that I know if it's the imaginary array is actually pushing out the bottom of this, and when it's sticking out the bottom, it should be touching something. So if it's touching something, then this number of hits variable, which gets run inside a fixed update, should be greater than 0. So basically, if we press the spacebar and we do the ampersands, so and this means, so if we press the spacebar and the number of hits is greater than 0, then that means we're definitely on the ground, and we press the spacebar at the same time, so we're able to add that force. So now in theory we have pretty much exactly as we had in the Bolt tutorial for the character movement for a simple platform game. So by running this, because testing is important, as I mentioned before, because it's a bit janky, it will work. And so when I'm on the ground, it will mostly always jump, but sometimes it doesn't, and we can maybe refine that later. But this time, it definitely, no matter how much many times I spam the spacebar, it's not going to jump when it's in the air. So yeah, that's the basics of a very, very simple character controller. In the next video, I might try and just make some minor improvements, because I'm not very happy with the fact that this doesn't detect a jump button every single time, because obviously you want to get that right, because it'll be very frustrating for the player if they can't jump when they press the spacebar.